Okay, I realized I started working out the practice 9.2 for you at the end of the 9.2 video lesson, but I wanted to work out the practice worksheet entirely. So I'm going to start fresh from number 1. It says 11% of the products produced by an industrial process over the past several months have failed to conform to specifications. The company modifies the process in an attempt to reduce the rate of nonconformities. In a random sample of 300 items from a trial run, the modified process produces 16 non-conforming items. Do these results provide convincing evidence that the modification is effective? Support your conclusion with a test of significance. When they say they want a test of significance, that is the 4-step process. You have to do the state, the plan, the do, and the conclude. You'll notice that they did leave you with a lot of space there, so you will have to do all the parts. So in the state part, we are going to start by defining the parameter that we will be using. So we do have proportions. We're going to do P is equal to the proportion of all products that fail to conform after the modified process. So we want to be very specific. We're looking at all of the products, which ones are non-conforming even after they started this new process. Okay? We're going to set up our null hypothesis to be P is equal to 0.11. You may be wondering, where does the 0.11 come from? It starts off by saying that it was producing 11% in the beginning were failing to conform. So 11% gives us the P is equal to 0.11. And then alternatively, we want to say P is less than 0.11. And the reason we're saying less than is because they're attempting to reduce the number that are failing to conform. Also, we need to remember to set our significance level within the state part. And so we want to say that alpha is 0.05. They did not give us a significance level, so we're going to go ahead and we're going to state it to be 0.05. That is the one you want to use if you're not given another alpha, or which we call the significance level. For the plan, we want to have 4 parts there. We want to have the name of the test we're going to use, and then the 3 conditions that we have to meet in order to use that test. So we want to do a 1 proportion Z test. We want to prove that we have randomization, 10%, and large counts. And it's not enough to just say random checkmark, 10% checkmark, large count checkmarks. You have to explain how we meet that condition. So random is met because it does say they took a random sample. So I have random sample as stated. We assume that 10% is met because 300 is how many is in our sample. We assume that that's less than 10% of all the products they make. You could also say we assume that the company makes 3,000 or more products. You can go the other way with it, but you have to prove 10% is at least assumed to be true. And then large counts, we have to plug in the values we have to prove that one is true. So we're going to do NP is greater than or equal to 10, and times 1 minus P is greater than or equal to 10. You have to go the extra step of plugging in the values. Do not stop right there at NP. Okay, so we have a sample size of 300. We have a proportion of 11%, so 0.11. 300 times 0.11 is 33, and yes, 33 is greater than or equal to 10. On the other side of it, we want to do sample size 300, 1 minus P. Well, P is 0.11, so 1 minus 11% leaves us with 89%. So 300 times 89% or times 0.89 is 267. So yes, that's also greater than or equal to 10. So we've done all the parts that we want for our plan. For the do, I'm going to go ahead and just work it out on the calculator. If you wanted to work it out by hand, then you would need to show the work for the z-score, and then you would either need to tell them you're going to look up the z-score on the table, or you would do normal CDF on the calculator, but you have to somehow show the work that you're doing in the do portion of your state plan do conclude. So I'm going to go to stat, over to test, and our 1 proportion Z test is number 5, okay? And so it's requiring that we do the hypothesized proportion, which is 0.11. We're going to do X from our sample is actually 16. And then they're taking it out of a sample size of 300. And then we want to tell them which way our alternative hypothesis is going. Is it a 2-sided not equal? Is it less than? Or is it greater than? And our alternative is less than because they said they're attempting to reduce the nonconformities, okay? So notice everything on my screen right now. I did write these in the do portion of my state plan do conclude. So now I'm going to calculate it, and all of the output is also going to be written down. So I have my z-score that it gave me is negative 3.137 when I round. I have my p-value. Be very careful with your p-value. When I first see that at first glance, I see, oh, my p-value is 8.5. Great, that's huge. That's 854%. Well, you can't have over 1, okay? You can't have over 100%. So pay attention. If you have anything over 1, you're going to need to move some decimal places. So I look at the end, and it says it's at -4. So I need to move my decimal place 4 places to the left. So I come around the 8, and then I add 3 more zeros. So it actually gives me 0.00085 for a p-value. They also give you p-hat. You might be wondering where the p-hat came from. If you do 16 divided by 300, it will give you the 0.053 repeating. Okay, so I just wrote all that information down. Notice I did not write the n is equal to 300 just because I had already put that in the previous stuff that I had entered into the calculator. And so I've got a p-value of 0.00085, and that's going to lead me to my conclusion. That is less than alpha. Okay, my p-value is less than alpha because we have a significance level or alpha of 0.05, and since p is less than alpha, we do reject the null hypothesis. Okay, that's the statistical conclusion that we're making. We need to then go and write it in context of what that actually means. So if we're rejecting the null, then we have convincing evidence that for the alternative. So I say there is convincing evidence that the proportion of all products that fail to conform after the modified process is actually less than 11%. We have convincing evidence that the alternative may be true, so we have convincing evidence that the proportion is actually less than 11%. Okay. Explain what the p-value of your test means in the context of this problem. That's just kind of that memorize the sentence, the one that I just love so much, that we did together on the 9.1 daily check, but you got to memorize what the p-value sentence is. So one way of saying it is, if the true proportion of non-conforming products is 11%, because that's the hypothesized claimed proportion, then the probability of getting a sample proportion as low or lower than the 5.3%, which came from the 16/300, the probability of getting that is 0.00085. It is that p-value. So the probability of getting a sample proportion as low or lower than the 5.3%, the sample data, would be 0.00085. Okay. Number 2. The germination rate of seeds is defined as the proportion of seeds that, when properly planted and watered, sprout and grow. A certain variety of grass seed usually has a germination rate of 0.80, and the company wants to see if spraying the seeds with a chemical that is known to change germination rates in other species will change the rate of this grass species. Suppose the company plans to spray a random sample of 400 seeds and conduct a two-sided test. Being that it's a two-sided test, you know that your alternative hypothesis is just going to be that your proportion is not equal to the 0.8, okay? They determined that the power of this test against the alternative, which they set to be p equals 0.75, is 0.69. We have a power of 0.69. Explain what this means in the context of the problem. So again, we have a null hypothesis. I just rewrote it because I kind of wanted to understand the scenario. I have a null hypothesis of 0.8. I have an alternative hypothesis. It actually is just that p is not equal to 0.8 because we have a two-sided test. But they went a little bit more specific and said, okay, well, it is 0.75. Like, we've done the test. We've applied the chemical. We found out that the new proportion is now 0.75. And so that is not 0.8, obviously. So what is our power? Our power is given to us as 0.69. That is the probability of rejecting the null hypothesis when the null is false. So you're correctly rejecting the null hypothesis. We have a probability of 69% of rejecting the null hypothesis when we should have, when it really was false. So you're saying that the germination rate is not 80%, and you're correct since there's evidence that the germination rate is 0.75. So 69% is the probability of rejecting the null when you're right in doing that, because it was actually 0.75. Okay, on 2B, I know we didn't go very in depth with power, and I know right now you're going, I have no idea what this is, even though she just explained one. But all I want you to really memorize is for this problem right here, for 2B, if you want to increase the power, then you need to increase the sample size and increase your significance level. I promise you it's going to be the same on the daily check. It's going to ask you, how do you increase the power? And you're going to tell me, increase the sample size, increase the significance level. That is it. There's no tricks to it at all. It won't be worded any differently. It'll be a different scenario, but they're going to ask you, how do you increase the power of the test? And you're going to say, increase the sample size, increase the significance level, and that's all you have to remember, okay? Part C, the company researchers spray 400 seeds with the chemical and 307 of the seeds germinate. This produces a 95% confidence interval for the proportion of seeds that germinate of 0.726 to 0.809. Use this confidence interval to determine whether this test would reject or fail to reject the null hypothesis. Explain your reasoning. I want to show you really quick where the confidence interval comes from. It's a good little review for you from chapter 8. I'm going to go stat test, and if we do alpha A, that was our 1 proportion Z interval, okay? They had 307 of the seeds that germinated out of the 400, and they did a 0.95 C level, and when you calculate it, that's where you can see the 0.726 and the 0.809. So they didn't just make that up, they actually created a confidence interval. So given a confidence interval, you have to look at your hypothesis claimed proportion. Our claimed hypothesized proportion was 80%. And you have to ask yourself, does 80%, does 0.8 fall inside of that interval? Yes, it does. If it falls in the interval, you fail to reject. If it's outside of the interval, then you reject. It's that simple when given a confidence interval. So remember that if the hypothesized claimed proportion is within your interval, then you fail to reject. If the hypothesized claimed proportion is either lower than your interval or higher than your interval, then you have to reject the null hypothesis. So where it says explain your reasoning, the way I started out is my explanation. Since 0.8, it's not letting me write on here. Okay, since 0.8 is in the 95% confidence interval, we fail to reject the null. Just because it is inside the confidence interval, it is a possibility.